Okay, so this is a chemistry leaving cert pass paper from the higher level paper 2008 question 11b, and it's on gas laws and the mole. Okay, so in the question we're told a little bit about vehicle taxation and CO2 emissions, and then we're told a little bit about the manufacturer's specifications for a certain diesel engine car is 143 grams of CO2 per kilometre, and it even tells us what this means. So that is that the car produces 143 grams of CO2 for every kilometre travelled. The car is used for morning and afternoon school runs totaling 8 kilometres per day. And then we have to use the manufacturer's CO2 emissions figure to calculate the amount of CO2 produced each day during the school runs in terms of the mass of CO2, the number of moles of CO2, and then the volume of CO2 produced at room temperature and pressure. And then finally, we're going to be asked to do the same question again for a larger SUV vehicle with a different CO2 emission rating. Okay, so the first bit of key information that we're told is that our car does 143 grams of 143 grams of CO2 per kilometre. And we're told that our car does 8 kilometres every single day. And the first question is asking us to calculate, so there's 8 kilometres per day. And the first question is asking us to calculate the mass of CO2 produced. And mass is going to be measured in grams here. Okay, so we have got 143 grams of CO2 produced per kilometre. We're travelling 8 kilometres every day, so we're going to multiply this by 8 kilometres per day, and that's going to equal 1,144 grams of CO2 per day. We can see our kilometres cancel out, we've got grams of CO2 per day. Okay, so on to the next part. Part 2. Now for part 2, we're looking for the number of moles of CO2. And from the last part, we've got the grams of CO2, so now we need to convert from grams to the number of moles. And to do that, we have to use the periodic table and the relative molecular mass, or relative atomic mass of our atoms. So the periodic table is on page 79 of your formula and tables booklet. And we have got a molecule of CO2, which is made up of 1 carbon and 2 oxygens. So carbon has a molecular weight of 12 grams per mole, and oxygen has a molecular weight of 16 grams per mole. But how many oxygens do we have? We've got 2 oxygens. So this is going to be 16 multiplied by 2, which is 32 grams per mole. So we need to add, for a molecule of CO2, our 12 grams per mole for the carbon and 2 oxygens, so our 32 grams per mole. So we've got 12 plus 32 is equal to 44 grams per mole. So what this is essentially telling us is that 44 grams of carbon dioxide is equal to 1 mole of carbon dioxide. But we're not interested in 44 grams. We're interested in 1144 grams of CO2. So we're going to divide both sides by 44 and find out what 1 gram of CO2 would equal. So 1 gram is equal to 1 over 44 moles. Okay, and now we want to multiply by our 1144. So 1144 grams is going to equal 1 over 44 times 1144 grams, and that equals 26 moles. So that's the answer to part 2. Now, for part 3, we're asked to calculate the volume of CO2 at room temperature and pressure. Okay, so we're looking for volume. Now, from the last part, we know that our number of moles is equal to 26. So we have to convert from the number of moles to a volume. Now, in our our formula tables booklet here, we can see that 1 mole of any gas is equal to 22.4 litres at standard temperature and pressure. But hold on a second. In our question, we're asked for the volume of CO2 at room temperature and pressure. So we can't use our 22.4 litres because that's standard temperature and pressure. And this is something that unfortunately we just have to remember. So 1 mole of any gas at room temperature is equal to 24 litres, not 22.4 litres at standard temperature and pressure. Okay. So we've got 26 moles. So 26 moles would equal 24 litres multiplied by 26. Let's see what that is. That is a volume of 624 litres. Now, that's the answer to that part there, part 3. Now we're asked a question, if a large SUV with a CO2 emission rating of 264 grams of CO2 per kilometre were used instead of the car mentioned above, how many more litres of CO2 would be released into the atmosphere per day during the school runs? So how many more litres? Now, there's 2 ways we could do this. We could go back and do all of our calculations again. We could calculate the number of moles, then we could calculate our volume and work it that way. So we could do it that way, but there's actually a simpler way of doing this. Because we know for the question that we just did, we've got 143 grams of CO2 per kilometre gave us 624 litres. So we've got actually a ratio here that we can use. So we're going to divide now by both sides by 143, and we're going to find out what 1 gram of CO2, what volume would that give us in a litre. So 1 gram of CO2 per kilometre is going to equal 624 divided by 143, and that gives us 4.36 litres. So now we can multiply this by our SUV, and we're told that our SUV has an emission rating of 264. So 264 grams of CO2 per kilometre. We'll now multiply this by 264 is 1,152 litres. Now a lot of people would just stop there and then move on to the next question. But we were asked how many more litres of CO2. So we've just calculated how many litres of CO2 will be released by this larger car. We haven't calculated how many more litres. So we know that the small car gave us 624 litres. And the big car gave us 1,152 litres. So now we have to do some subtraction here. So we have to subtract our 624 from our 1,152. And that equals 528 more litres. And that is the final answer to that question.